Hi class. So today we'll be dealing about a very important concept, and that is shielding. There is a couple lot confusion on this term. So let me try to address it off the bat so that we are able to nip all our doubts and we need to nip it in the bud. See, shielding is a kind of misnomer. It's in a way not the exact what a student will be able to organically understand. To make it with more clarity explain, what I say is take a shell. Assume there is some charge at the center. Assume that charge is whatever symbol at the radiant is the symbol of the charge. Does mean consonant with the lingo that we are using nowadays. So what I intend to do is I have to take a charge which is lying somewhere over here, Q. I assume this distance is d2s. And the charge on the surface is capital Q. If surface is conductor, which it is, if this is conductor, we say that the charges are shielded from each other. Charges are shielded from each other. Please be very careful about it. What do we understand of the word charges are shielded from each other? Charges are shielded from each other is to do more with effective field than individual field. Were the question rephrased and asked, will there be field generated by Q at the center or not? Solo, in isolation, a question on Q, small q is asked. And at the center is the point where I want to calculate field generated by it. Certainly we are to say field generated will be K, Q and whatever the distance square of it. This will be field generated by small q at the rate. Then if field is generated, how we say it is immune. How we say it is shielded. It is not about solo field generation. Solo field is generated. This field will redistribute the charge on the surface, and this redistribution of charges are getting redistributed. So the redistribution of charge will make the net field inside of it 0. So you take everything, you take induced charges, you take redistribution of charges, you take outside charges, collectively they will add in such a manner, and they are all vectors, so they will add in such a manner so as to get field inside 0. So field inside is 0. It's not due to small q alone, it's not due to charges on the sphere alone. Yeah, you can say it is collective effect. Now charges on the sphere will be the charge that you have according to it plus the charge induced. Induction will not get a net charge, so redistribution, we have to take everything into account. Vectorially, it will sum up to 0 every point inside, but it is collective effort. This collective effort should not be misunderstood as there is no effect due to small q. There is effect, and that effect is this. In fact, there is effect due to the charges on the sphere as well, which will be negative of this. So when we say that they are shielded, it doesn't mean that field due to them will vanish in thin air. Field will still be there, but net will be 0. Net will be 0 will be called shielding. I'll set an example. Let's say you are being pulled from both the sides by two individuals. They are applying equal and opposite forces, you are not moving. And as you are not moving, there is a person who is making an observation on you. The person says that you are immune to the force applied by person number 1. He's right. You're not moving. Yeah, you're not moving because there are two forces equal and opposite, so you're not moving as effective. You are not to move, effective force on you is 0. So effective is the concern over here. but the person who makes an observation may state that person number 1 you are immune to, or person number 2 you are immune to. In a similar manner over here, we say that charge Q is shielded from at the rate, or at the rate charge is shielded from Q. It's collective effect, yet being said in a form which makes it slightly misconstrued in Hamburg. You are to understand the totality of it. So this was one question I wanted to deal. The other question which I wanted to deal is, what is the other form of Guass's theorem? This is read in the class, the gradient of gram, which we did the other day. If we take dot of gradient with field, then we get it as rho by epsilon naught. This is a Gauss's equation. You can shape it to what I have written on board, the regular one, the feature one. What is important about it? We can get rho. An example I have says that E is given to you. Let's say E is equal to A x I cap, and you are to figure out what will be rho, what we are. And from here to check, it will be dEx by dy is equal to what was rho by epsilon naught. I am not writing the other. First it is pleasing, and second, you know that only x component is out here. So we will differentiate. We will get A is equal to rho by epsilon naught. So rho is equal to A epsilon naught. Okay, thank you. See you later.